Okay, our last section is modeling motion with parametric equations. It's really a neat section, getting you able to apply what we're doing to some real life situations. So if a projectile is launched at an angle of 0 degrees with the horizontal, with initial velocity of magnitude v, or vector for v, so just a vector, and this, remember, magnitude is a speed, right? The speed of velocity basically is all it's saying. The path of the projectile may be described by the equations. The x value can be found by taking the time t times the magnitude times the cosine of the angle given, of theta. And the y value can be found as t. This is just the initial velocity is all this is. That's what this set up here is, just the initial velocity times sine of the angle given plus 1/2 times the gravity times t squared. Now this, when you get to calculus, we'll derive this a little bit farther to show you where this equation comes from here. All right, but the reason they don't give you a solid number here for gravity because it makes you, because you have to put in what unit we're using. If we're using meters per second, gravity is 9.8 meters per second, and actually negative 9.8 meters per second. And if you're talking about feet per second, it's 32, negative 32 feet per second, because gravity is always acting downwards on you. That's why it's negative. Okay, so let's do a couple examples. It's really not as bad as what you think. So here we are. Football player kicks a ball with initial velocity of 40 feet per second at an angle of 40 degrees with the horizontal. After 0.8 seconds, how far has the ball traveled horizontally and vertically? So if we just need to plug in some information. His horizontal velocity is represented by t times its initial velocity. His initial velocity was 40 feet per second. Okay, times the cosine of the angle which it was kicked at the horizontal, so cosine of 40 degrees. Its y value is t. Remember, t is our time, it's our unknown in this case. Our velocity is 40. Sine of 40 because that was our angle. Sorry, I shouldn't have made those numbers the same, but I did. Okay, but anyway, that's our angle. Plus 1/2 gravity in this instance. Let's see, what are we talking about? We're talking about feet per second. So this has got to be negative 32 then. Instead of 9.8 meters per second, it's negative 32 t squared. All right, now to finish the question off, all it's asking you to do is how far has the ball traveled horizontally and vertically. To figure out its horizontal distance, we plug it into x. So all we do is we plug 0.8 in to that equation and solve. And I'm not going to do it now. I don't have my calculator out, and you can do that. Type that in your calculator. And what you should get when you do that problem, you should get 24.5 feet. If you didn't get that, first thing to do, make sure you check that your calculator is in degrees. And again, here, all we're going to do is we're going to plug in 0.8 for t everywhere we see t. And when you do this on your own, you should get 10.3 feet. Okay. So there is example number 1, not overly difficult. Again, I'm trying to make this short here, so we're going to move to 2. Here in this case, an archer shoots an arrow with an initial velocity of 60 meters per second and an angle of 4.8 degrees with the horizontal at the target 70 meters away. If the bow is held 1.4 meters, off the ground, how far off the ground will the arrow be when it hits the target? So this is a slightly different question, but we can still write our equations the same. It's horizontal distance, remember, we use x equals t cosine theta, right? X equals t times the initial velocity times cosine of theta. So we go here. X equals t times its initial velocity. Its initial velocity was 60 meters per second times cosine of the angle which it is with the horizontal. Okay. And its vertical can be written as t its initial velocity, which is 60, times the sine of 4.8, plus its gravity, right? Plus 1/2. This time we're using meters per second, so negative 9.8 t squared. And there's one more thing about this. There's one more slightly different thing about this. It's telling you that the bow is held 1.4 meters off the ground. And so the only thing we do is just like if I have a parabola, you know that y equals x squared normally starts at 0, right? But if I want to move it up, say 5 units, I write the equation y equals x squared plus 5. It's just a vertical shift. So if I want to vertically shift my graph, I need to add it to my y's, so plus 1.4. That's the only difference there. All right, except for now the process. They want us to figure how far off the ground will be, how far off the ground will the arrow be when it hits the target. Well, first off, they don't give us any time. Oops, they don't give us any time. So we have to solve for time. We have to solve for t, but there is one thing that we know. We know that the target is 70 meters away. So we know that its horizontal distance is 70 meters. So if we know that this is 70 meters, we can solve for time. Cosine of 4.8. And to solve for t, obviously, we just divide both sides by 60 times cosine of 4.8. Again, make sure your calculator is in degrees. I have to type this real quick on my calculator. So 70 divided by 60. 60 times cosine of 4.8. Remember, when you divide, if you're doing it all in one step, you need to put parentheses around 60 times cosine of 4.8. Otherwise, it'll just divide 70 by 60 and then multiply by cosine of 4.8. You won't get the right answer. So we end up getting t equals 1.17 seconds. So now that we know the time in which it takes the arrow to get 70 meters away to the target, so if I shot my arrow here, if I started here, and my target is sitting right here, and this is 70 meters away, it took me 1.17 seconds to do this. Well, now we just got to figure out how high we are going to be up. So all we do now is go to our y equation, and that tells us the height of the graph, right? So we want to know how high it is at the end. So we want to know how high it is at 1.17 seconds. So you just plug in 1.17 seconds into here and here. And when you do that, you should get approximately 0.56 meters. Anyway, I try to give you a short run through of modeling parametric equations with motion. I hope this helps. We'll see you in class.